Warm glaciers and cold glaciers. To those who have given no thought to the matter, it may seem a little silly to talk about the temperature of glaciers. After all, aren't all glaciers cold? This is true only in a relative sense. There are varying degrees of coldness, and the differences between glaciers at or close to melting temperature and those at 10, 20, or 30 degrees below 0 Celsius are profound. For these reasons, glaciologists like to speak of warm glaciers and cold glaciers. We shall shortly see what the basic differences are. Climatological environment is, of course, the controlling influence in determining the temperature of a glacier. The number of factors involved is relatively large, and their interrelations complex and not clearly understood. Such factors as air temperature, wind, condensation, evaporation, and melting all play a role in determining the temperature of a glacier. There is no way to make a glacier cold other than to build it up out of cold snow or chill it by outgoing radiation or conduction to the atmosphere. A glacier can be no colder than its environment unless, for some reason, the environment has suddenly become warmer and the glacier has not yet adjusted to the change. Obviously, a glacier cannot be warmer than the melting temperature or it wouldn't exist. But are there glaciers at the melting temperature? Yes, there are, and since most of the snow that makes up glaciers accumulates at temperatures below freezing, there must be some means of warming it to the melting point in such glaciers. One would expect that incoming radiation and conduction from a warm atmosphere could do the job. But these factors are effective only as long as the surface materials, snow, fern, and ice, are below the freezing point. Radiation does not penetrate in significant quantities to a depth of more than a few inches, and once the surface layer of finite thickness has been raised to the melting temperature, conduction is no longer effective. This happens because the surface layer is at 0 degrees Celsius throughout, no temperature gradient exists, and consequently no heat conduction can occur. This brings us to an important point. The subsequent warming of the underlying material is accomplished mostly by the downward movement, percolation, of water from the surface. A little of this water may come from rain, but mostly it is derived from melting of snow through conduction and radiation at the surface. The water moves downward freely through the underlying pervious snow and fern. It produces only a little warming by conduction, for it is at close to 0 degrees centigrade, but it eventually refreezes in contact with the colder underlying materials. Each gram of water gives up 80 calories of heat as it changes to ice. This is sufficient to raise the temperature of 1 gram of ice by about 160 degrees Celsius, or 160 grams of ice by 1 degree Celsius. Clearly, then the refreezing of downward percolating melt water can be the major mechanism for warming up snow, fern, or ice, and it is the basic cause for the existence of warm and cold glaciers. Have a great day.